Pythagoras. So Pythagoras is used to calculate a side of a right angle triangle. So the formula for Pythagoras is c squared equals a squared plus b squared, where c is your longer side, which is your hypotenuse, and then your other sides are a and b. It doesn't really make a difference as to which way around you do that. You can swap these around, a and b, which is fine, but c is always the hypotenuse. Now let's say we know that a is 3 and b is 4, and we're asked to work out what c is. Then we simply plug these numbers into this formula, c squared equals a squared plus b squared. So c is the unknown, so we leave that as it is. C squared equals a, which is 3 squared, plus b squared, which is 4 squared. So let's simplify. C squared equals 9 plus 16, and then c squared equals 9 plus 16 is 25. Now to get rid of the squared, we need to square root both sides. So we're left with square root 25, which is equal to plus or minus 5. However, as we're dealing with a length here, we know that it can't be negative, so the answer must be 5. Now let's look at another example. Let's say we know that the hypotenuse is 5, and we know one of the sides, say b, is 3, and we are asked to work out what a is. So in this case, again, we use the Pythagoras theorem, c squared equals a squared plus b squared, and we plug in the numbers. So c is 5 this time, so we go 5 squared equals a, we don't know, so leave that as a squared, plus b squared, which is 3 squared. We simplify, so we have 25 equal to a squared plus 9, which then we simplify, we take away 9 on both sides, we're left with 16 equal to a squared. Now to get rid of the squared, we square root both sides, so we're left with a square root 16. So a is plus or minus 4. But as said in the previous example, a length cannot be negative, so the answer here is 4. So a equals 4. Now here we said that the a was unknown and the b was known. However, if we swap them around, the procedure would be the same, except we would replace a with the number that we know, and b would be the unknown, and we would rearrange in the similar manner. Let's look at another example. So here we're asked, find the length of the diagonal of a rectangle that has length 11 meters and width 10 meters to 2 decimal places. So for these sort of wordy questions, where they're talking about shapes or graphs, etc., it's a good idea to draw a diagram. So let's do that. So here we have a rectangle, and let's add the information we know, 10 and 11, and we're asked to work out the diagonal. So now here we can see that this is effectively a right angle triangle, and we're asked to work out the hypotenuse. So here we need our Pythagoras theorem. So c squared equals a squared plus b squared. Now c is the hypotenuse, that's our unknown, and 10 and 11, let's just put this the other way to our previous example, b and a. It doesn't matter which way around you label these, and then we simply plug in the numbers. So we have c squared equals 10 squared plus 11 squared. 10 squared is 100 plus 11 squared, which is 121, c squared. And then we simplify, so we have 221. And to get rid of the squared on the c, we square root both sides. So this becomes c equals square root of 221. So c equals 14.87 to 2 decimal places. Now we chose 2 decimal places here because that's what is asked in the question, 2 decimal places. Hence it's useful and important to always read the question twice to ensure that you're not missing something that's quite straightforward and can be easy marks in the exam. Let's look at another example. So here we're asked, find the length of a side of a square where the length of the diagonal is 2 meters to 2 decimal places. So again here we will draw a diagram. So here we have a square, and now we will add the information that we know about this from the question. So we know this is a square, so all the sides have the same length. So let's add that information in. A, and A. And we know from the question the diagonal is 2 meters, so let's put that as 2. And we're asked to work out one of the sides. Well, here again we will use our Pythagoras theorem. So it's c squared equals a squared plus b squared. Now here, in this case, we know that our a and b, for this right-hand triangle here, are the same. So we can replace this with a squared plus a squared is equal to c squared. Now c is 2, so we can replace that with 2 squared. So we have 4 equals 2a squared. So we simplify, we divide both sides by 2, so we're left with 2 equals a squared. So we square root both sides, and we have a equals square root of 2. So a equals 1.41, and that's 2 decimal places, just like we were asked for in the question. Let's look at another example. So here we have a ship sails 8 kilometers due north and then 5 kilometers due west. How far is it from its starting point? Give your answer correct to 2 decimal places. So let's say our starting position is here, and we're told that the ship goes north 8 kilometers and then it goes west 5 kilometers, so it ends up here. And we're asked how far is it from its starting point. So essentially we are looking for the length of this green line. Now this is effectively a right angle triangle, so we can use our Pythagoras theorem, which is c squared equals a squared plus b squared. Now labeling the triangles, the hypotenuse is always c, and then the other sides are a and b. So let's plug in the numbers. So c squared stays as it is, a squared is 5 squared, plus b squared, which is 8 squared. So here we simplify. So c squared is equal to 25 plus 64. C squared equals 89. And we square root this to get c equals 9.43 to 2 decimal places, as the question asks for it in 2 decimal places. Let's look at another example. So here we have a rectangular room that has length of 8 meters, width of 7 meters, and a height of 2 meters. And we're asked to calculate the diagonal of the room from floor to ceiling. So first we have a rectangular room. So let's draw a diagram. And we are told that it has length of 8, width of 7, and a height of 2. And we are asked to calculate the diagonal of the room from floor to ceiling, presented by this red line here in the diagram. Now we know that we have the Pythagoras theorem as a tool to work out diagonals, which is c squared equals a squared plus b squared, but that only works on right angle triangles. Now for the triangle that has this red line, blue line, and here, which is a right angle triangle, we only know 2, the height. We don't know the length of the blue one, so we need to work out the length of the blue line first. Now to work out the length of the blue line, because we know the length of 8 and the 7, as this on the ground is also a right angle triangle. So here we have c as our hypotenuse, so we leave that as it is, c squared equals 7 squared, one of the sides, doesn't matter which one, plus 8 squared. So here we have 49 plus 64 equal to c squared. So this simplifies to c squared equals to 113, and then we take square roots and we're left with 10.63 to 2 decimal places. So now we can replace this c with what we just calculated. So let's just put 10.6 here. However, when we calculate the red line using this new information, we need to use the full number in the calculator, so the complete number. So again, we're going to use Pythagoras theorem again. So let's say c squared is equal to a squared plus b squared. And c stays as c, as we don't know that, it's the red line. A squared, which is 10.6 squared plus 2 squared. So we simplify, while 10.6 squared is reversing over here, so we know that's 113 plus 4. So this simplifies to c squared equals to 117, which when simplified gives us c equals 10.82, 2 decimal places. And that is the answer to our question to calculate the diagonal of the room. So essentially here we had to draw the question on top of the diagram in terms of what we need, and the information we have to calculate what we need to calculate, and then we had to apply Pythagoras theorem twice to get the answer. One to get the blue line, and then using that information to get the red line. Let's look at another example. So here we are looking to find the height of the rectangular room that has a length of 10. So let's say that is 10, and the width is 9, and the length of the diagonal is 21. So here we're going to use Pythagoras, but we're going to use it twice. So we're first going to use our 10 and our 9 to work out the hypotenuse of this right angle triangle, the diagonal of the base of the rectangle. So let's call this x. So x squared is equal to a squared, which we can say is 9 squared, plus 10 squared. So x is equal to 81 plus 100. So x is equal to square root of 181. So let's leave that as it is, as we know we're going to use it in the next step. So here we use the same formula again. So our Pythagoras, c squared equals a squared plus b squared, and we plug in our numbers. 21 squared is equal to x squared plus what we don't know, let's just call it b as well, so b squared. So let's call that y, so say y squared. Now we know that x squared is equal to 181 from here, so we can say the 21 squared is 441 equals to 181 plus y squared. Then we take away 181 from both sides, we're left with 260 equal to y squared, and then we square root both sides, so we're left with y equals the square root of 260, which is equal to 16.12 to 2 decimal places, as required in the question. So here we have the diagonal of a rectangle exceeds the length by 1 centimeter. If the width of the rectangle is 7 centimeters, find the length. Give your answer to 2 decimal places. So here we're going to start again with a diagram, and we're going to add the information we know. So we are told that the diagonal of the rectangle exceeds the length by 1 centimeter. So we need to draw the diagonal, and we're told that if the width of the rectangle is 7 centimeters, so let's just say that's 7, and the length we don't know, so let's just call this x, and we're told the diagonal exceeds the length by 1 centimeter, so this is x plus 1, and we're asked to work out the length. So here we have the 3 sides, and it's a right angle triangle, so we're going to use our Pythagoras theorem. C squared equals a squared plus b squared, and c is x plus 1, so let's replace that, so it's x plus 1 all squared. A, we'll just label this one as a and this one as b, doesn't really matter which way around it is. So this is 7 squared plus x squared. So now we need to expand the left hand side, the x plus 1 squared, so this becomes x squared plus 2x plus 1, which is equal to 7 squared plus x squared. We can cancel this with this one by simply taking x squared off on both sides. We simplify the next step, which is 2x plus 1 equal to 49. So this becomes 49 minus 1, and minus 1 on this side. So this simplifies to 48, 2x. So x here is 24. So that means our length is 24 centimeters, as our units were given in centimeters. Now, as an aside, how did I get from the x plus 1 squared to x squared plus 2x? So x plus 1 squared is the same as x plus 1 multiplied by itself. And then we take the first term from the first bracket, x, and multiply it through by the second bracket. And then we take the second term and we multiply that through the second bracket. So this now we need to multiply through into each term. So it becomes x squared plus x, and then plus 1 times x plus 1, it doesn't change anything, so it's just 1 times x, which is plus x, and 1 times 1, which is plus 1. So this simplifies to x squared plus 2x plus 1, which is what we had over here.
You can download the application on Google Play or App Store, and you can visit our website mathslegends.co.uk.